Hello everyone, this is Chandrakiran from CAD section in SRIT Institute of Technology. So today I am explaining the topic about Lagrange's mean value theorem. Introduction to Lagrange's mean value theorem, a fundamental concept in differential calculus. So basically what is the Lagrange's mean value theorem? Lagrange's mean value theorem explains the relation between the average rate of a change and the instantaneous rate of a change of a function, and it says that the instantaneous rate of change at some point C within the interval equals the average rate of change over the whole interval. And next, historical background of Lagrange's mean value theorem is it was named an Italian mathematician Joseph Louis Lagrange in 1736-1813. Although he stated the theorem clearly and formally in 18th century, the ideas behind it were developed gradually over many centuries. And next, the formal statement of Lagrange's mean value theorem is if f of x be a function such that it is continuous on closed interval a comma b and it is differentiable on open interval a comma b, then there exists c belongs to a comma b such that f dash of c is equals to f of b minus f of a by b minus a. And next, conditions for this theorem is the function f of x must be continuous on the closed interval a comma b, and the function f of x must be differentiable on the open interval a comma b. And next, geometrical interpretation of Lagrange mean value theorem is there exists a point C where the tangent to the curve is parallel to the secant line joining points a comma f of a and b comma f of b. And next, the secant line is the line connecting two points on curve a comma f of a and b comma f of b. Its slope given by f of b minus f of a by b minus a. And next, the tangent line is the line that touches the single point c comma f of c, slope given by f dash of c. And next, importance of Lagrange's mean value theorem is it foundation for proving many calculus results. And next, helps understand the behavior of differentiable functions, and it is widely used to estimate errors in numerical methods and approximations. It shows that for any smooth curve, there exists at least one point where the instantaneous rate of change equals the average rate of change of an whole interval. And next, we see example problem. Verify the Lagrange's mean value theorem for the function f of x is equals to x cube minus x square minus 5x plus 3 in 0, 4. Let f of x is equals to x cube minus x square minus 5x plus 3 is a polynomial in x, and it is continuous and derivable for every value of x. In particularly, f of x is continuous in closed interval 0, 4 and derivable in open interval 0, 4. Here, by applying the Lagrange's mean value theorem, there exists a point C in open interval 0, 4 such that f dash of c is equals to f of 4 minus f of 0 by 4, 0. Therefore, 3c square minus 2c minus 5 is equals to f of 4 minus f of 0 by 4. Let it be equation 1. And next, f of 4 is equals to 4 cube minus 4 square minus 5.4 plus 3 equals to 64 minus 16 minus 20 plus 3. That implies 67 minus 36 is equals to 1. And f of 0 is equals to 3. And next, f of 4 minus f of 0 by 4 is equals to 31 minus 3 by 4 equals to 1. From equation 1, we have 3c square minus 2c minus 5 is equals to 7. That implies 3c square minus 2c minus 12 is equals to 0. And therefore, c is equals to 2 plus r minus square root 4 plus 144 by 6 equals to 2 plus r minus square root 148 by 6 and equals to 1 plus or minus square root 37 by 3. Therefore, 1 plus square root 37 by 3 lies on 0, 4 and LMVT is proved. And next, the conclusion for Lagrange's mean value theorem is Lagrange's mean value theorem establishes a fundamental link between the average rate of change and instantaneous rate of change of a function. There exists at least one point in the interval where derivative equals to the slope of the curve. This theorem forms many advanced results in calculus. So this is all about a Lagrange's mean value theorem. Thank you.